Using the transformer pipeline makes it quick and easy to start working with language models. Let's now do a deeper dive into what this pipeline is actually doing and try to understand the steps a little better. The first step of the pipeline is to tokenize our input text. So to do this, we want to import the auto tokenizer from the transformers package. Next, we need to specify the model we want to use. This will ensure the tokenizer tokenizes in a way that is suitable for our intended model. Different models will have slightly different ways of creating their tokenization. So we're going to be specifying our model, and we'll be using BERT base uncased. We'll cover more of this model in detail in the next section of this course. We then want to call the pre-trained tokenizer for this model. So we create our tokenizer and then use auto-tokenizer.fromPretrained and our model. Let's see how this tokenizer works by running it over a sentence. We'll take again the sentence, "I'm so excited to be learning about large language models." We then want to call the tokenizer on this sentence. So we'll create our input IDs and then use the tokenizer over our sentence. Let's now print out these input IDs and inspect them. We can see three things have been generated here: input IDs, token type IDs, and an attention mask. The token type IDs are used for some models where we want to distinguish one sentence from another, or an input sequence and its relative classification. We can use numbers to distinguish one sentence from another, where tokens with the type ID of 0 would belong to the first sentence, and token types with ID of 1 would be the second sentence or the classification. We'll come on to this more when we look at specific models in more detail later in this course. The attention mask essentially tells the model which words are important to pay attention to. Again, we'll cover this later in the course. For now, I just want to focus on the input IDs. The first thing our tokenizer does is break out our sentence into tokens. We can call this step directly using the following. So we want to create our tokens, and then we can use tokenizer.tokenize over our sentence. We can then print these tokens out and see that this sentence has been converted into tokens for us. These tokens are then converted into a numerical value based on a predefined vocabulary specific to the model. Let's have a look at these. We'll create our token IDs and then use tokenizer.convert tokens to IDs over our tokens. Let's then print out these token IDs. We can see that for each token, this has been converted into a numerical representation. We can decode these token IDs back into tokens to check this. So let's create some decoded IDs and use tokenizer.decode over the token IDs. When we print these decoded IDs out, you can see that we're back to our original sentence. Let's look again at the token IDs. You'll notice that the token IDs are present in the input IDs we were given when we ran the full tokenizer. However, if you look at the input IDs again, you'll see there are some additional numbers that haven't been printed when we just look at the token IDs. So, what are these? We can decode them to check their meaning. Let's run tokenizer.decode 101. This has printed out a token of CLS. Let's then run tokenizer.decode 102. And we can see we have another special token here, which is SEP. These are special tokens added by our tokenizer, and our next lesson will cover exactly what each of these special tokens mean. The tokenization process does change depending on what model we want to use, as each model has its own unique requirements for the input data in terms of its format, tokenization strategy, and use of special tokens. Let's look at how XLNet, another large language model, differs in its tokenization. So let's specify our model as XLNet base cased, and we'll create this as our model 2. We then create our tokenizer 2 and use autotokenizer.fromPretrained model 2. This will load up the tokenizer for the XLNet base cased model. Let's now call this tokenizer on our sentence. Again, we've been given a list of input IDs, token type IDs, and an attention mask. But you can start to see some differences here. The numerical values given to each token are different, and the token type IDs now contain more than just zeros. Let's first look at how this model tokenizes differently to the BERT model above. We'll run tokenizer2.tokenize over our sentence. When we print this out, you can see that even just the way that this model has tokenized the text looks very different to what we saw above. We can then convert these tokens to their ID values. So we'll use tokenizer2.convert tokens to IDs over our tokens. And when we print this out, you can see that the numbers given to each of the tokens differs again from the BERT model above. You might also notice that where the BERT model started the input IDs with this CLS special token, XLNet doesn't begin the input IDs with this special token at all. Instead, we see 2 extra numbers at the end of our input IDs. Let's decode them and see what they mean. We'll run tokenizer2.decode, and we want to decode the number 4. We can see that again we've been given the SEP special token, just in a slightly different format. And if we run tokenizer2.decode over the number 3, we can see again this CLS token, again just in a different format. But what are these special tokens, and why are they added to our input sequence? Let's move to our next lesson to discuss this in more detail.